Over the last lectures, I extensively mentioned how Node works with asynchronous code, and I mentioned this event loop, which is important. Let me dive deeper into that and deeper into how Node.js exactly executes your code to stay performant and still be able to handle long-taking tasks like working with files or things like that. Because there is an important concept which you have to understand, well, what is happening behind the scenes. So in our Node application, we have our code. And one important thing to understand and to really keep in mind is that Node.js uses only one single JavaScript thread. A thread is basically like a process in your operating system, you could say. So it's only using that one thread, and the obvious question is, how is it then able to handle multiple requests? Because if we're not able to assign a new thread for each request, they ultimately end up all running in one and the same thread, and this of course poses a security question. Can you then access data from request A from request B? And most importantly here at this point when we talk about performance, there of course also is the question of, does this not mean that if the request A is still doing work, request B can't be handled? Well, both is taken care of Node.js, and at this point of time here, I want to focus on the performance question, though I'll also briefly touch on the security question. Now let's start with the performance. Let's say we have some code which accesses the file system, as we already did in this course too. Now, working with files often is a task that takes longer, because files can be very big and it doesn't necessarily complete instantly. Therefore, if we're doing this upon an incoming request, a second request might have to wait because we're not able to handle it yet, or it even gets declined. So basically our web page is down for that user. Now, one important construct I already mentioned is that event loop. The event loop is automatically started by Node.js when your program starts. You don't have to do that explicitly. Node.js does that when, well, it basically starts running code. This is responsible for handling event callbacks, though. So all these nice functions we basically added thus far in create server, for example, the event loop is responsible for basically running that code when a certain event occurs, you could say. It's aware of all these callbacks and basically, executes that code. That doesn't help us with our long-taking file operation though. And it's important to understand that this operation is not handled by the event loop. Just the callback that we might have defined on write file once it's done. That code will be handled in the event loop, but that code will finish fast. So basically, the event loop will only handle callbacks that contain fast finishing code. Instead, our file system operation and a couple of other long-taking operations are sent to a worker pool, which is also spun up and managed by Node.js automatically. This worker pool is responsible for all the heavy lifting. This worker pool is kind of totally detached of your JavaScript code, you could say, and it runs on different threads. It can spin up multiple threads. It's closely intervened with your operating system you're running the app on. So this is really detached from your code. And this worker pool is therefore doing all the heavy lifting. If you're doing something with a file, well, a worker from that pool will take care and will do its job totally detached from your code and from the request and from the event loop. The one connection to the event loop we will have, though, is that once the worker is done, so for example, once we read a file, it will trigger the callback for that read file operation. And since the event loop is responsible for the events and the callbacks, this will in the end up in the event loop. So there, Node.js will then basically execute the appropriate callback. Now, this is a lot of behind-the-scenes stuff, which is nice to know. You don't have to write any code to make this work. This is all built into Node.js, and if you write code as you learn it in this course, you automatically take advantage of this. I still, of course, want you to understand how that works behind the scenes, because I believe that helps you understand Node.js better. Now, let's look into that event loop then. That event loop is in the end a loop which is run or started by Node.js that keeps the Node.js process running, and as I just mentioned, that handles all the callbacks. And it has a certain order in which it goes through the callbacks. So basically, it's a loop that just, well, keeps on looping, unsurprisingly. At the beginning of each new iteration, it checks if there are any timer callbacks it should execute. We haven't set up any timers yet, but basically there is set timeout and set interval. You might notice from front-end JavaScript 2, there these methods also exist. Now in Node.js you can also set a timer, and basically you set a timer and always pass a method, a function that should be executed once that timer completes. And Node.js is aware of this, and at the beginning of each new loop iteration it executes any due timer callbacks, so any callbacks that have to be executed because a timer completes. Then as a next step it checks other callbacks. For example, if we had write or read file, we might have a callback because that operation finished, and it will then also execute these callbacks. Now be aware that with I/O here, I mean generally any input-output operations that typically is file operations but can also be network operations, and in general I'm talking about blocking, long-taking operations. Now it's important to understand that Node.js will leave that phase at a certain point of time. And that can also mean that if there are too many outstanding callbacks, it will continue its loop iteration and postpone these callbacks to the next iteration to execute them. After working on these open callbacks and hopefully finishing them all, it will enter a poll phase. The poll phase is basically a phase where Node.js will look for new I/O events and basically do its best to execute their callbacks immediately if possible. Now, if that is not possible, it will defer the execution and basically register this as a pending callback. So this is how that works. Important, it also will check if there are any timer callbacks due to be executed, and if that is the case, it will jump to that timer phase and execute them right away, so it can actually jump back there and not finish the iteration. Otherwise it will continue, and next set immediate callbacks will be executed in a so-called check phase. Set immediate is a bit like set timeout or set interval, just that it will execute immediately, but always after any open callbacks have been executed. So typically faster than set timeout with 1 millisecond of open duration, let's say, but after the current cycle finished, or at least finished open callbacks that were due to be handled in that current iteration. And now we're entering highly theoretical terrain, and I don't want to dive too deep into that, though you will find a couple of resources that do dive deeper at the end of this module, in case you want to join the Node.js team and really dive super hardcore into this. Now we're nearing the end of each iteration cycle, and now Node.js will execute all close event callbacks. So if you registered any close events, and in our code we haven't, but if you had any close events, this would be the point of time where Node.js executes their appropriate callbacks. So roughly spoken, we have timer callbacks, we then have any I/O related callbacks and other event callbacks, and set immediate, followed by close event callbacks. So close events are basically handled separately, or their callbacks are handled separately, we should say. Well, and then we might exit the whole Node.js program, but only if there are no remaining event handlers which are registered. And that is what I mean with this refs equal null thing here. Internally, Node.js keeps track of its open event listeners. And it basically has a counter, references or refs, which it increments by 1 for every new callback that is registered, every new event listener that is registered. So every new future work it has to do, you could say. And it reduces that counter by 1 for every event listener that it doesn't need anymore, every callback it finished. And since in a server environment, we create a server with create server and then listen to incoming requests with listen, This is an event which never is finished by default, and therefore we always have at least one reference, and therefore we don't exit in a normal Node web server program. We can call the exit function, as you already saw, and if we do anything else, like at the beginning of the course, when we just used Node to execute a file that did not listen to a web server or on a web server, then it also finishes eventually once it's done with its work. So this is how the event loop works. And this can be very theoretical. All these different phases typically don't matter to you, certainly not when getting started with Node.js. Now consult these advanced resources if you want to learn more. For now, just be aware of that first picture I showed you of how Node.js handles complex work, that there is this worker pool that takes care that your things are not getting blocked, and that it therefore stays performant. Now, I also touched on that security thing with that one JavaScript thread. And regarding that, we also got no problems by default, though I will come back later to how we can manage global data and how we should manage it to ensure that we do not spoil data from request A to request B. By default, we have some separation because remember that callback method in createServer, it's executed for every new incoming request, and therefore this function only runs for that incoming request, and anything we do to the request or response object there will not be exposed to other request or response objects because each function is only scoped to itself and not accessible by the other functions. So by default, we have that separation due to how JavaScript works. Now that was a big chunk of theory. Again, not something you have to learn by heart, but something where you should at least keep that big picture in mind of how Node.js manages its work.